Okay guys, the last thing I want to talk about in section 5.3 is an application problem. So I'm just going to do one with you to try to keep the video as short as possible. If you watched the videos, I believe it was 7.1 in the AP video that I had you guys watch, it talks about things being proportional or inverse proportion problems. So hopefully that will help in this type of a problem. So I'm going to start at the beginning here where it says the rate of change. So when you see any type of an application problem, this is going to show up on the AP exam for really the whole thing because it's free response now. You have to be able to decode all of these things. So this first part where it says rate of change, that means I have a derivative. I'm not doing a derivative, but I have one. So I need to write that as almost like a dy dx setup, but I have different variables here. So this is a rate of change in the number of foxes, n of t. I'm just going to call that n because I don't want to write n of t every time. And then it's in a population, and the t right here tells me that I'm talking about this with respect to time. So as time goes by, this is what's happening to the population. So the rate of change would be dn dt. And then they told me that that is, which means it equals, directly proportional means I can take k times whatever it is they're telling me it's proportional to. So in this case, 550 minus n of t, I'm just going to call that n. So 550 minus n. T is the time in years. And then they give me some information here. So they're giving me, right here, they're giving me an initial condition. So everything that we talked about in this lesson, if you're going to find a particular solution, which they're asking me to do right here, they want me to find the population when t is 5. That means I have to have an initial condition to go off of. Sometimes I need more data than that. So in this one, they actually gave me a second piece right here. That's pretty important too. So we'll see how that comes into play in a minute. So the first thing I would do is separate my variables. So I really want to get my n's together. So I'm just going to keep all of that together, those two little circled things. I'll just leave the k over here and the dt. K is just a constant, so don't forget about that. You could have called it c if you wanted. I always call it k if I'm talking about proportion. Okay, so I'm going to leave my dn over here, and I'm going to move just my dt over here for now. And then I'm going to go ahead then, I need to get my n's together, so I'm going to take all of this right here and divide by it. I could have chosen to distribute this, but then it starts to get a little messy. If I move this over, it's pretty quick and easy. So I'll show you how that works out. So this, if I divide by this, that would be 1 over 550 minus n dn equals k dt. So if I go to integrate this, I'm going to use u substitution for this. I know that 1 over something, like 1 over x, that is just a natural log. So if I can say u in this case is going to be 550 minus n, so I'm going to do that up here. U is 550 minus n. Well, that means that du is -1 dn. Had to remember what variable I was using there. So that means if I just want dn, I need to move this -1 over. If I divide by -1, I get -1 du equals dn. So I'm going to replace then down here, I'm going to say this is really the integral of 1 over u, but it's -1 over u du because it's -1 here. And that equals the integral of k dt. So now I'm going to actually integrate it. So this would just be a negative natural log of u, but I'm going to go ahead and plug that back in so I don't have to do it later. So 550 minus n. And then I don't have to put my plus c on that side. Equals, this is going to be k And then, so remember this is a constant. So let's say this was 2. The integral of 2 would be 2t in this case. So I'm just going to call this kt because I don't know what that constant is, and then plus my constant at the end. Okay, so then we got to try to clean this up a little bit. The first thing I don't like is this negative right here. I'm going to go ahead and push it over to the other side because I can deal with it better. I'm going to try to get rid of this natural log, and this might take some reminders for you. So we need to remember our natural log rules. So if we take, if you remember, e and natural log are kind of like opposites of one another. So if I take e to this, I can kind of remove this, but let me show you what it does over here. I have to do it to both sides. So this can go away and just become my 550 minus n, but this side over here is going to look really messy. It's going to be e to the negative kt minus c. So I just raised e to that power. That's this rule right here. Sometimes I like to do this, e, and then this to me just cancels. I don't know that that's actually a nice way to do that math, but that's how I remember how to do it. Okay, so then let's go ahead and keep solving for n. So remember, I'm trying to get n by itself to give myself a general solution, and then I'm going to plug in my unknown, or my initials up here, my initial conditions, to get a particular solution. Okay, so if I minus 550, that'd be negative 550 plus my e to the negative kt minus c. And then I'm going to multiply by a negative or divide by a negative. So n equals 550 plus minus e to the negative kt minus c. Okay, now something we can simplify a little bit here. So this e, I'm going to write it up here, e to the negative kt minus c. I want you to remember your exponent rules. I could rewrite this as e to the negative kt times e to the negative c. Now there's a particular reason why I'm doing this. If I have e to some exponent, remember e is a constant, it's just a number. So I've got a number to a negative constant exponent. So I have a constant to a constant exponent. That's just a constant. This right here is really just a constant. So I could rewrite this as c e to the negative kt, and that will help in the end just make things a little bit simpler. So I'm going to rewrite this as 550 minus e, I'm totally messing that up. Okay, c e to the negative kt. That's what n equals. Okay, so that is my general solution. I am now going to go back up here and say, okay, how can I use this information to help me? So I'm going to start with my initial condition. So if n equals, that means 250 equals, because n is the population, that's 250, equals my 550 minus, I don't know what c is, e to the negative, I don't know what k is, but I do know that t time is 0 right here. Okay, so let's think that through for a second. This again is a constant to some exponent that's multiplied by 0. That means this is e to the 0 power. Well, anything to the 0 power is 1. So this is really 1 right here. Okay, so I'm going to minus my 550. That gives me negative 300. And then negative c, or negative 1c, is by itself, so that means c equals 300. Okay, so let's plug that in and let's see what we have. So go back to your general solution. N equals 550 minus c, I now know is 300, e to the negative kt. So the problem with this solution is I still don't know what k is. That's another constant. I could have called this like c1 and then this one's C2 if I wanted. But I have two different constants there. I've got to figure out what the second one is. That's why I needed this second piece of data right here. So let's plug that one in. N is 500, or the population. And then T is 3. So this is really negative 3T then, or sorry, negative 3K. Because T is 3. Okay, so then let's solve this out. So first let me minus my 550. So that's going to give me negative 50 equals negative 300 e to the negative 3k. Okay, let's divide by this negative 300. So 50 over 300, that is 1/6 equals e to the negative 3k. And just like earlier, I undid my natural log by using e. I'm now going to get rid of my e by doing the natural log. So the natural log of 1/6 equals this exponent, negative 3k. So what I need to do is divide by negative 3, so I really need this, the natural log of 1/6 divided by negative 3. That's going to give me what k is. So if I do that on a calculator, I just punched that in already earlier, so I'm going to write it out here. I got this. And that was rounded, so I'm saying that's about what it is. Okay, so that means my particular solution, or my general solution, is really messy, but it's a little bit better than just having these two constants in it. So n equals 550 minus, my c was 300, and then e to the negative k, which was 0.59725 t. That is really messy. Hope you can read that. Okay, so my last step, they wanted me to figure out what is the population when t is 5. So after 5 years, what's happening? So I'm going to plug 5 in for t right here. If I do that, and I calculate all that out, I get about 535. It definitely doesn't come out that perfect, but what I wanted to think about is what unit should I be in here? So I'm talking about n is my population, and it's the population of foxes. So I wanted this to be a whole number because I'm not going to have a fraction or a decimal of foxes. So I have about 535 foxes. And that's my final answer to that.